All right, so I have taken all the problems, and unfortunately, I did not think to bring my binders home with me. So I redid the majority of the problems for the questions that you asked, and I'm not going to go over all parts of all the questions, but I did kind of redo them so that I could scan it and explain them. All right. The first submitted question was number 53 on 3.4, which I did, I think, go over the first day that I answered questions on this one. So here is the given problem. It gives you a rate schedule for basically the charges on a natural gas bill. And there were three categories: monthly service, delivery charge, and natural gas cost. So the monthly service was a flat fee that is not per therm. The delivery charge, they charge you for any usage. So the first 30 therms are at this rate per therm. Once you go over 30, that's it. So the 0.91686 times 30 is the max charge for delivery. The natural gas cost itself, if you use 30 or fewer therms, you get this smaller rate, but then after that, it hikes up. Now, again, remember, like I explained in class, this is for the over 30. You are still being charged this lower rate for the first 30. So if you use 40, the first 30 of them are charged at the lower rate, the additional 10 at the higher rate. So that's how that works. So part A said, what is the charge for using 20 therms in a month? So I showed my work in pieces. So monthly service plus delivery at 20 therms plus the cost of the natural gas of 20 therms. Only the lower rate. There is no higher rate because it's less than 30. So then I simplified all of that, and because we're talking about money, I rounded that to the nearest cent. So then in part B, what is the charge for using 150 therms in a month? So very similarly, I started out with just putting in the monthly service fee and the delivery charge for the first 30 therms. This plus 0 you don't really need. I do have additional therms of usage, but there's no charge for that. Here's the part where you have to use that 150 in the right way. The first 30 at this lower rate, the remaining amount, so 150 was the total, but it's only the remaining amount. So I have to subtract 30. So this should be 120 times the higher rate. So then I added up all those pieces together. Again, we're talking about money, rounded it to the nearest cent there at 119.97. Part C, develop a function that models the monthly charge C for X therms of gas. So I broke down my work over here and the final answer over here. Needed to move that over so you could actually see it. So again, if our usage is between 0 and 30, that's one way to find the total. So the number of therms used, which is going to be between 0 and 30, is my X. So I have these two rates that are both multiplied by X. So right here, this number comes from adding these two like terms together. The 2344 is a flat rate. So that just stays. So that's how we got this. Again, make sure that you have noted that this piece is only if X is between 0 and 30. If X is greater than 30, then much like we did in part B, we have to do the service rate. Then I have to charge for the first 30 therms. So this is the charge for the delivery. This is the natural gas usage for the first 30 only. But then I have the higher rate times the overage. Well, the overage is how much I used minus 30. If you look at part B, I used a total of 150, but it was 120 that I multiplied times this higher rate. So that's why this is x minus 30. And I showed my work down here distributing the 0.50897, which gives me 0.50897x. But then when I multiply that times the negative 30, that's where I get this negative 15.2691. So now all of these guys are just constants. So I combined all of those like terms because when I multiply times 30 here, it's just a number. That's where this 43.6225 comes from. And then obviously this guy comes from just the higher rate. So hopefully that helps you understand that if you didn't before. In 3.5, number 56, this was your original function. And it asked you, I think it said to graph and to show, work basically for at least 3 points and to list the domain and range. So I drew out the original parent function and I labeled it. So that's this guy here. And I wrote out at the top the 3 original points that I always graph on that parent function. Then up here, I wrote out what the transformations were. This negative is on the outside, so that's a reflection in the x-axis, which means I'm going to be multiplying the y-coordinates by -1. So times -1 on y is what a reflection in the x-axis does. A vertical stretch is times the number, so in this case 4, on the y's, because again, it's vertical. So these two together, they're both multiplying. I'm multiplying by -1, multiplying by 4, which means that what I really did on the y's is multiply by -4. So you can see that I wrote that under each of the y coordinates. The only other transformation was this h value here, which means to move right 1. If I'm moving right, that means I'm adding 1 to the x coordinates. So you can see that work below as well. So then I just applied that to all of my original coordinates from the parent graph. So add 1 times -4, add 1 times -4, add 1 times -4. And these are my 3 points that I then use to graph. So 1, 0 here to -4, 5, -8, and then of course I connected with the shape. The domain there, the x's start at 1, including it, so bracket, and they get bigger, so 1 to infinity. The range values go from -infinity to 0. Please, please, please make sure that you're putting domain and range in the correct order. It has to go from lowest value to highest value. So in this case, -infinity, those values are smaller than 0. It does matter. You can't do bracket 0, comma, -infinity. It always has to go from lowest to highest. All right, next, had quite a lot of questions on 3.6. I'm not going to do all the parts of all the problems. So I'll go over parts of them, but a lot of them, once you have the function set up, you should be able to go from there. So here we're told that p equals x comma y is a point on the graph of y equals x squared minus 8. It wants you to express distance d from p to the point 0, -1 as a function of x. So because we know that y is x squared minus 8, that means that instead of x comma y, my point is really x comma x squared minus 8 for my first point. My second point then is 0, 1, because that's what I'm finding the distance between. So in the distance formula, we subtract the x coordinates and square it, and then we add that to the subtraction of the y coordinates and squaring those. So here's my work. X minus 0, square it. X squared minus 8 minus -1. Minus negatives become pluses. So this actually becomes x squared minus 7 squared. So then I had to simplify. I drew a little arrow here. When I FOIL this out, x squared minus 7 times x squared minus 7, I get these, And then I still have this x squared over here that's a like term with the negative 14x squared for a total of negative 13x squared. So here's my formula once I've simplified. Both part B and part C are just a plug and chug. This one wasn't really a word problem, but since most of the section is, if you rounded this one, I'd probably be okay with it in this case, but you can see my work for plugging those in. Part D, so use a graphing utility to graph it. So in your Y1, you simply type in this whole thing, and then you just need to find an appropriate window and some exact points. I already have this exact point when x is 0, y is 7. That's this one right here. And in part E, you have to use the graphing calculator to find these 2 points. So that should make it pretty easy to draw an accurate graph there. So for what values of x is D the smallest? So in class, we did a second trace max. This is second trace min. I'm not going to show you in the graphing calculator because we already did that together. But again, it's the, you have to set y1 equal to this equation in A, adjust your window, and then do second trace choice 3. These over here are what the calculator spits out when you do that second trace min both times. And so then I rounded my answer. I said x is about positive and negative 2.55 because it says for what values of x. So it doesn't ask what is the smallest distance. If it did, the y value would be the answer, but it's asking for the x there. All right, moving on then, number 9 was asked about. Number 9 is very similar to the example that we did together in class, except that it's not a semicircle, it's an entire circle. So they gave you the equation, they gave you the picture. Because the point that we are looking at is in quadrant 1, that means that the y coordinate, when we solve for y, and I put the work back over here, like, you know, subtract x squared from both sides, square root, we know that the equation of the circle really has the plus or minus, but the plus is the top half of the semicircle, and the minus is the bottom half. So if my point P is in quadrant 1, then I know that this y is the positive version of 4 minus x squared. So this really is using the same function as the one we did together in class. But here's the other difference. When I go to express the area, my dimensions aren't the same as it was in the semicircle because the semicircle's rectangle stopped on the axis. This doesn't. So I know that if this point is at xy, that this distance here is x, and this one here is y. But this time when we look at my dimensions, the base, if you will, it's not x, it's 2x. And the height is not y, it's 2y. So again, I have to replace y with this function. But that's how I get my area. So my area, I am taking the base, which is 2x, times the height, which is 2 times this equation. So when I simplify this function, I get 4x radical 4 minus x squared. When I do the perimeter, it's the same thing because I'm doing 2x plus 2x plus 2y plus 2y. And again, we don't actually use the y, we use square root of 4 minus x squared. So 2x plus 2x plus 2y plus 2y. And then I just combined like terms for the perimeter. I am not going to show you the graphs or go over the answers for the next two because it's just like what we did in class. So I've written out what you type in your y1 or y2 and which function you should be using. Again, both of these ask for what value of x we are doing. So you're not looking for the y coordinate, you're looking for the x coordinate there. On number 10, I'm going to hope y'all asked this because you just wanted to check your answer. But this guy, I think we should have been able to get ourselves. So it wanted the area of a square. So we know all the sides are the same. If the inscribed circle has radius r. Well, all radii of a circle are congruent. So this is r, which means the side length of the square is 2r. So area of a square, both the sides are the same. All I did then was simplify this. And same thing with perimeter. It's 4 times the side length, and we can simplify that there. 24, it says it's an open box with a square base. This is the key. If you did not read that word square, you would have some problems here. It says it's supposed to have a volume of 10 cubic feet. So I wrote out over on the side here how we would find volume. We know that the base has to be x by x because it's a square. And the height is what we need to be able to write in terms of x because I can't use a third variable h. So I wrote out volume equals x times h. And then because I know the volume is 10, I can then solve this for h by dividing by x squared. So 10 over x squared would be the height of this box. Now, it's asking you to express the amount of material used. That's asking for the surface area. And remember that this is an open box, which means this top is not included. So I've got 5 sides. The bottom that's x by x, or x squared would be its area. And then all 4 of the other sides have its base as x and then the height. So the 4 comes from the fact that there are 4 identical sides. So I'm adding the same thing 4 times. This right here is the individual area of one of those sides. When I simplify this, this x cancels with 1 that's in the bottom. So 10 over x is the area of an individual side. And then I have 4 of them. So that gives me 40 over x. These are not like terms, cannot combine them. B and C are plug and chugs. So take this, plug in the values that they gave you. I'm not going to do those for you. Same with the graphing. For what value of x is A the smallest? So graph it in your graphing calculator. You can go to second graph to get the table if you need points to put on your own personal graph. What is the least amount of material needed? That's going to be the y value at that minimum. Last one, very similar. Again, I'm only going to show you this first part. Open box with a square base made from a square piece of cardboard 24 inches on a side by cutting it out a square from each corner and turning up the sides. So if all of these little squares are x by x, that means all the dimensions are x. If this whole side was 24, then that means that both of these sides here that I've kind of put the little braces around, the whole thing was 24. I've taken away 2 x's. So that's where 24 minus 2x comes from. The height of the box when you fold it up is this x length that was cut. So volume is going to be length times width times height. 24 minus 2x times 24 minus 2x times x. So all I then did, I squared this guy, so foiled it out, which gives me this. Then I distributed my x, and then I simplified it. So this is my volume function. Part B, part C are plug and chug. Take this function, plug in 3 and simplify. Plug in 10 and simplify. Then D and E using your graphing calculator. Graph, put in your y1, 4x cubed minus 96x squared plus 576x, and do second trace max. Largest, that max point, the x coordinate is what D wants, and then the y coordinate is what E wants. All right, hope that helps you get everything fixed on your papers and have them ready for when you walk into class on Monday.